I'm going to talk about my PhD thesis or doctorate thesis, which I just finished last year. I'm glad to be here, and my talk is on lift and shift of model code using machine learning microservices in SaaS applications. So the study basically has been done for the period of four years, and so SaaS applications have increasingly been increasingly developed a need for machine learning frameworks, and this has been quoted in the literature by Philip Rao and others recently. And the importance of machine learning in SaaS applications and AI in SaaS applications has tripled or quadrupled in the past year, with several of them adopting such AI assistant tools. Additionally, there is also another need which is increasingly important to discuss, which is the porting or the lift and shift of models from one application to another application. This lift and shift of models is something new because several models are being built in recent times, and the effort is to lift and shift these models to nearby sister applications or related applications at each. So the study has two subjects. One is machine learning frameworks, and second is how they can help lift and shift of ML model code in enterprise applications. So we devised a framework called Minerva, and the next generation called Contain in Siriusmindshare Labs. And the idea is to make this porting of ML models and quicker, which means ultimately innovation is quicker. This need has also been identified by Vidya Lakshmi and Kumar in recent times. And this need to innovate quickly has quadrupled with the advent of generative AI in recent years. So, with the help of this open source framework that we have in GitHub called Contain, people can make avail of portable ML microservices and innovate quickly. But since it's a research objective, we are not stopping at just devising the framework. We are studying, or I have studied how it accelerates innovation, how it accelerates deployment of ML models, how it accelerates porting of ML models. And what we are talking of in this mechanism is porting of ML code, which is different from transfer learning. We are talking of porting of ML code itself to a new application. And the framework that has been designed called Minerva or Contain the next generation supports all the necessary ingredients that we discussed or challenges in recent times for SaaS applications. In particular, one additional benefit of this new framework is that it can coexist in on-premise and cloud. There are a lot of legacy applications still, about I would say 50% of the applications are still on legacy infrastructure, and our framework actually works with them without them migrating to cloud. So that's one new novel benefit, which is only served by Acumos, which is another framework devised in past 5 years. And the other novelty is, which nobody addresses, is that we have studied the portability of ML models across applications, and this framework helps accelerate that, which nobody else does. So the research methodology has been to study efficiencies. And efficiency we study by measuring speed of development, speed of deployment, speed of porting, and also to make sure that this framework that is devised is real life purpose. We use variety of load tests on it to make sure it scales properly. The data that has been used to fuel this study has been developed from real life use cases. It's called purposeful sampling as described by ML et al. In 2013 in their book. This purposeful sampling means you devise samples from real life use cases and not simulations. So we have used these data sets to devise our experiments. The first experiment is whether microservices means ultimately having a modular or independent ML service that can be separated out from the rest of the system to serve ML needs and SaaS applications. Whether that addition of that ML microservice benefits SaaS application in terms of portability, deployment, and other efficiencies. That's one ablation study. The second ablation study is on top of this ML microservice, if we include something called the data layer, can we port ML model from one application to another? And these are sister applications, right? They might be things like MailChimp and Constant Contact, which are sister applications, SaaS applications, or there might be things like in the olden times, Responses and Eloqua. And there could be several other sister applications which are quite close by. And so the idea is to study whether the porting of the models between these related applications increases in speed with the inclusion of a data layer in the ML microservice layer. And then we also study different contexts. It is well known that most of the enterprise applications have in the same company have related applications, but can we do every study and can this microservice work across different companies' SaaS applications that are still related because of the competition, free competition? There is always another version of the same application somewhere else that needs the same ML model code. Can it be ported across such applications when it is permitted? And then, of course, we do load testing of the device microservice. And it's called ML microservice because it can, and also AI microservice because it can pretty much be built and develop any ML model or AI model. This is how a typical enterprise application is. There's a data layer in the middle, which consists of data processing, orchestrations, etc., and transformations. There is the application layer on the top, which is the UI platform of the application and other things at the top. And at the bottom, we are saying there is a ML microservice layer, which interacts with all the upper two layers to achieve ML or AI models into the application. And the device solution called Minerva or Contain, the next generation, has 3 layers: core, stub layer, and application layer, apps layer. Apps are basically another synonym for ML model in our language, in our paper. This microservice that we devised has REST APIs, multiprocessing, job tracking, train and predicts, online and batch, and security related concerns are addressed through various secure protocols like HTTPS. There is Dockerization of the whole solution, which is why it works between legacy and on-premise without a problem. The abstractions are at the middle. These abstractions are for things like versioning, storing other models, and exceptions and things like that. And the apps, which is the model layers, you can pretty much devise any ML models as well as any ML or AI code by implementing the interfaces provided by the abstraction layer. So this is the solution or a high code. So because of the need for porting, we have devised 3 porting mechanisms: high code, low code, and no code. High code is when somebody actually writes hundreds of lines of ML model code and rewrites them, and the study evaluates how long it takes to rewrite them manually. That is like the baseline on its high code solution. And of course, this is a ML service. So this is the API interface for that ML service. Then the no code solution, which means that to shift models, lift and shift is our terminology that we coined. This lift and shift can be done through JSON configurations, which are listed in the table. These no-code solutions help to achieve minor changes needed when you move models from A to B. And then we have a low-code solution. Now, this low-code solution means it is become possible recently because there is LLMs and chat GPTs and other solutions which can now write code automatically. And we have studied how long it takes to write the new code, to devise small experiments to port models, ML model code, using mappers from generative AI, and the speed which this can be done with. Now, the results of this speed or efficiency evaluations, the first finding is that just by introducing a microservice, you have significant improvement, or you basically double your speed of building ML models just by introducing a microservice layer or high code solution. Even the deployment is generally deployment activities are independent of the underlying complexity of the code. So deployment, there is not much significant lift in the efficiency. Now the no code solutions also has a 2x improvement, but it's not significant because our experiments were meant for realistic small models, and these small models have lesser lines of code. So the no code solution did not significantly give a lift or statistical significance. Now, when we introduced the data layer, so earlier studies was just for the microservices. Now, the next experiment is to introduce the data layer to achieve porting of the code. And the porting of the code has a strongly significant lift due to introduction of a data layer. Now, the data layer is something which can be automated through generative AI, which is our next result. The generative AI, when you automate the data layer, the results are not significant lift over the previous optimizations. Now, several companies they have thousands of engineers. They have already been optimizing for them. These big companies that are really at their game. For them, they might not see a significant lift with small models when you introduce generative AI, but for traditional companies or traditional IT organizations, when you introduce generative AI, when it compares with their original mechanism of in building ML models, generative AI can significantly accelerate porting of ML model code from one application to another. That is a corollary and a common knowledge base as well that generative AI will significantly improve when you are starting from scratch. And the experiments for load testing said that this system that we devised is capable of about 10 RPS, requests per second, and can serve online requests quite reasonably. In conclusion, there can be a 1.15 to 2x faster adoption innovation. Now, when models are being adopted by some other applications, the innovation is spreading. So this innovation can be 1.15 to 2x faster. And the layer design, which is introducing microservices, then introducing data layer, then introducing generative AI, this kind of layered service can help structure your innovation as well as structure your organization's development groups or AI organizations. The open source contain ML framework, which is a derivative and a smaller version of the original solution, is a big step forward in the strategy to build any AI ML model and port it. That lift and shift that we call and port it with 1.15 to 2x faster speed. And lastly, generative AI in the past 2-3 years has been a great phenomena which helps this porting of ML model code. And finally, our solution or the proposed innovation or research says that the device solution actually is compatible with both legacy applications, which are about 50% at least in the world, and the new breed cloud applications, which are the rest of the 50. So that's in short my talk, and I thank my Oracle team. I see